Hello everyone. I guess we are live. So hello everyone. And sorry for the yesterday's stream. So it was like it's my problem. All of a sudden my laptop gave me hand in the middle, so it got stuck. Sorry for that. I guess we are good now. Okay. So yeah, let's start with a small intro. So myself, Vamsi, currently working as an associate software engineer at SNNS Hyderabad. I'm in 2021 undergrad, passed out from Bheemreddy Engineering College, Kurnool, Andhra Pradesh. So we started this particular preparation, like Python interview preparation course, 15 days back. Okay, till now we have completed 11 lessons, and this is going to be 12th lesson. Okay, so like we started from the Python basics. Okay, basics of Python, and we came till today a recursion. Okay, so in between we have solved all the problems on some fundamentals. Okay, fundamental topics for programming, and like very important topics for interviews, and the problems. Okay, problems as well, all the basic problems. I guess it will be more over 20 plus problems, I guess. Okay, we have solved around 20 plus problems, and which are repeatedly asked in an MNC companies. Okay, MNC companies like TCS, CTS, and like Wipro, Infosys kind of companies. Okay, interviews. Okay, like I'm not saying for an OA, like online assessment. So nowadays online assessments have become little tougher, like at least coding. Okay, so like Infosys, yeah, if I take an example of Infosys, it is getting little tougher day by day. Okay, I've seen the recently questions as well. So they are a little like so before this pandemic has started, that was in basic questions only. Okay, like I did apart from few specific roles, Infosys won't ask programming for all the roles. Okay, all the fresher roles, but nowadays it is asking programming like at the level of medium questions. Okay, medium, not even easy levels. Okay, they are asking medium level questions. Okay, for I guess 5 lakhs LPA, like there is something like SES, so specialist engineering role, and PEP role. So yeah, like yeah, if you are very good at DSA, and if you know some basics of DS, then I can say you can solve two problems. Okay, like if you are good at problem solving. Okay, and if you are good at problem solving, and if you know some like basic knowledge on programming, then you can solve that. Yes, hi Shraddha. But there will be a third question which requires an DSA for sure. Means they are asking in terms of DP, or even I have seen graph question. Yes, I have seen graph. And for medium level questions, they will be asking more on backtracking, or backtracking and hashing kind of stuff. But it's okay. Okay, if you know some basic DS, and if you have solved some 100 plus problems at least, then you can able to solve at least two problems, I guess. Okay, so yeah, cool. So yeah, nowadays interviews are getting tough. Like OAs are getting tough, but I'm pretty much sure that these companies interviews are getting like little easier for everyone. I don't know the reason why. Maybe the companies are not interested in taking up more interviews, or not making the interviews very seriously. So earlier they are making OA as very simple. Okay, like before COVID, I can say before COVID, OA simple means online assessment, and interviews are getting little tougher. Okay, interviews were a medium kind of thing. like easy to medium. So what is a DSA? I'm interested in it, but I belong to MEC. Ishan, like DSA is nothing but it's a combination of data structures plus algo. Okay, algo. So what is data structures in the sense we'll get to know, okay, maybe after 10 sessions or something like that, like arrays, linked list, trees, graphs, hashing. Like hashing is not an data structure, but yeah, it's a kind of like, okay, remove this hashing. Okay, so these are all the uh, data structures. Now when I say algorithms, algorithm is a kind of problem solving thing, kind of problem solving, like using DS. Okay, using your data structures, you will be solving some problems, okay, in programming world. So uh, those are, you are calling them as an algorithm. Okay, so this is called as a predefined thing. Okay, so yeah, that's about it. And yeah, so the roadmap is pretty much simple. Okay, learn any one language, like be good at it. When I say be good at it, like you might have solved around 50 plus basic problems using loops and recursion kind of thing. Then start oops. Okay, make sure you will be picking up an language which is an object oriented programming, because it will be a good choice. Okay, when you are in interview, you can easily expect oops questions in an interview. Okay, so that's why I ask you to, if you are learning something new, for like if you are starting from the scratch, start with any, pick up any oops language, like so C++, Java, Python, something like that. And then after learning these things, like a DS implementation, like so there were like if you have taken C++, there is an HTML library. If you have taken Java, there is a collections library. Okay, like if you have taken Python, there is again collections, and you can use your list tuples as your data structures as well. But I highly recommend you guys to try to implement those data structures on your own. Okay, like you will be having predefined things, but it will be good if you know how that things, like how that particular data structures works internally. Okay, on my experiences I can say that internal implementation is very very important. Okay, so I have asked this kind of internal implementation in many interviews. Okay, so that too in product based companies only, not even in service based companies. Okay, like if I said a stack, so they will ask you to implement stack using a linked list. They will ask stack using arrays. Okay, you can expect. Okay, no one can say no, I don't know how to implement stack using linked list. Okay, all you need to know is you need to know the concept. Okay, whenever it is required, you need to implement that thing. That's it. Okay. Yes. Okay. Cool. Now let's get start with another new topic. Okay, called recursion. So what do you know about recursion? Please let me know in the comments chat window. What do you know about recursion? What do you know about recursion? So like I forgot to give the recap. We didn't had an session on yesterday, but on previous on Tuesday we had sorry, on Monday we have discussed about functions and types of arguments in it. Okay, so that's why we are saying today we are showing recursion. Okay, so a function calls itself. Yes, good. A function calls itself. So what is that? Like if you are in, just assume if you are in an interview, if someone, like if your interviewer asks you to define recursion, so if you say a function calls itself. Okay, if you say this answer, he will again ask you to define an recursion. Okay, so here the thing you need to identify, like the thing you need to remember here is, So whenever you are saying something in an interview, just make sure that like your interviewer knows the answer. Okay, so he wants to know how can you elaborate that particular topic, or how can you elaborate that particular word. Okay, so that is what he expects, he or she. Okay, so here if someone said recursion, okay, so it's okay. So first tell this answer, okay, tell this particular definition, then tell one example. Okay, like let's take an example. Okay, where let's say you will be having a problem of okay, counting or sum of natural numbers, sum of natural numbers. Okay, where I will be giving you n. Okay, you need to add all the numbers till the end, and you need to give me the result. I guess we have solved this problem using two methods earlier. One is loops, another one is standard formula, right? So n into n plus 1. So yeah, that works. And now my requirement is to solve this particular problem using recursion. How can we do this? So you are saying that I can say, okay, just remember this word called recursion means doing same task repeatedly until you can't go further. Okay, until you can't go further. Let's say let's say so whenever you are talking about recursion problems, you need to identify one thing for sure. Okay, so you will be, let's say you will be given a big problem. Okay, something like this, big problem. And when there is a possible way, when there is a possible way of making this big problem to the small chunks. Okay, small chunks. Okay, and if you can relate this, like if you can relate all the chunks. Okay, let's say, so let's consider this as a first 2 3 4 5 6 7. Okay, if you can relate, or if you can find a way to solve the chunk 2 using chunk 1. Okay, so you know the answer for chunk 1. Okay, and now by using that chunk 1 answer, can you able to solve the chunk 2? If your answer is yes, then you can use the answer, like you can use the recursion technique. So what I mean, so here, if you find relativeness, in an answer, or if in an problem, then you can use recursion. So basically for most of the people will feel recursion is a little complicated topic. Okay, so because it is tough to identify, yes we can solve this problem using recursion, yes we can solve this problem using dynamic programming. So it's tough to identify. So what I can say, so how to identify a problem whether it's a recursion or not. So just try to make this, remember for this particular formula. Okay, and this particular method. So this is your first thing, and this is your second thing. And if both the conditions has been satisfied, then you can say that yes I can solve this problem using recursion. Okay, and again like dp is another world. Okay, we can come to dp and while discussing some that dp topic, but as of now just remember this recursion. Okay, so let me know, are you good till now? Are you good till now? Are you good till now? Yeah. So now let's go and I have given one problem, right? I have given one problem, right? That problem is sum of n natural numbers. Okay, Here I will be giving you n, okay, n as 5, okay, n as 5. So let's say here the big problem is 5, biggest problem is 5. Now if I write this, how can I represent this thing? How can I represent this? So can I represent it as a 1 plus 3 plus 4 plus 5? Yes, can I? Now we can visualize that this is the problem. Okay, I need to do this particular 1 plus 2 plus 3 plus 4 plus 5. Now how can I solve this problem? Now just remember, so can I break down this problem? Let's try to divide this particular problem into small chunks. Okay, now if I want the sum of 5. Okay, I want the sum of 5. Okay, I want the sum of 5. Okay, I want the sum of 5. So can I say that the sum of 5 is 5 plus sum of 4? Can I say that? I don't know what is sum of 4. I don't know sum of 4. Okay, I don't know sum of 4. But I can feel that there is some relativeness here. Yes, agrees everyone? Now my problem has been reduced to finding the sum of 4. Finding the sum of 4. Yes. Now how can I write the sum of 4? How can I write the sum of 4? Can I write 4 plus sum of 3? So are you getting any relative path? Are you getting any relative path? Yes, relative path. Now can I write the sum of 3 as 3 plus sum of 2? Sum of 2. Yes. So I don't know what is the sum of 2 as well. Okay, what I will do, I will go 2 plus sum of 1. Sum of 1. Now tell me, so can I divide that one as my another chunk? So here I know that whatever sum until until 1, the sum is 1. So this is the fact I know. This is the smallest subproblem that I can solve. This is the smallest subproblem that I can solve. Yes, I can't go further down that. Okay, I don't need to go as well. Okay, I don't need to go as well. So at that time, what I can do? I can say, so whenever I have called sum of 1, I will return just 1. Done. I know the answer. I know the answer of what is the sum of 1. So I will return 1. Now let's dig deep. Okay, let's dig deep. Okay, so now we got the answer for sum of 1. So here what is the statement here? Here it's a 2 plus sum of 1. Sum of 1 is replaced with 1. So what is the answer now? It is a 3. It is a 3. So this particular line, it's a 3. So who is calling this particular line? Who is calling? So sum of 2 is calling. So I need to give this answer to the sum of 2. Sum of 2 is 3. Okay, sum until 2 is 3. Now what is the answer here? It is going to be 6. It is going to be 6. Now who called this particular sub problem? Who called? Who wants this sum of this particular line? So it required for sum of 3. So I will return 6. Okay, sum until 3 is 6. Yes, are you getting? Are you getting or not? Why we are doing this? Are you getting or not? So as you said, okay, a function calls itself. And I said that if you have attended previous class, we have talked something about a call stack. A call stack. Okay, where you will be storing all your function calls. Okay. Yeah, if you don't know, we'll see. Okay, we'll talk about that as well. It's no worries. Okay, now what is the sum here? Okay, it's a 10. Who called this? It's a sum of 4. So 10. So now the sum here is 15. Who called this? Sum of 5 has called this. So I will return 15 here. Done. My job is done. My job is done. So what we did, so if you recollect what we did, so we have done just two steps. Okay, we just believed in one fact. Okay, what we know, like what is the smallest sub problem that we can solve. Okay, so we know that that is a 1 for sum of 1, like sum until 1 it's going to be 1. We know this particular fact, and from this fact we built our solution. Yes, agrees that everyone? Because we built our solution with this fact, because there is a relativeness. Okay, there is a relativeness between the next sub problem and the current sub problem. Then only we can apply recursion. Okay, so can I say everyone got it till now? Any confused? Any confusion? Please let me know. Okay, if you are confused, otherwise we can just go and try to convert our logic to the programming. Okay, program. Now here after like you find that yes, we can solve this recursion, you need to find the recurrence relation. What is this recurrence relation? You need to figure out recurrence relation. You can call this recurrence relation as a generalized formula. Generalized formula. What is this generalized formula? So here the generalized formula means every time what you are doing, so just represent these numbers in terms of indexes. Okay, just represent these things, whatever you are doing in your like tree, recursion tree, like you have to call this as a recursion tree. Okay, so you need to represent all these things in terms of indexes. Now can I say this as my n? Okay, if I say n is equal to 5, now what will be this sum of 4? What will be the 4? So if I am representing 5 as n, then this particular 4 will become n minus 1. Yes, n minus 1. So can I write, so each time, now coming to this particular sub problem, my n is 5. So this is what I am finding for. Okay, I am searching for sum of 5. Okay, sum of 4. So here my n is 4. Okay, so this 3 will become n minus 1. So I can write a generalized formula as n plus sum of n minus 1. Okay, done. So you need to return this, that's it. Okay, let's go and try to code. Okay, let's go and try to code. Yeah. Okay, so let's say I will be print. I'm assuming I have a function called sum of n. Okay, so where I will be passing some n value. Okay, now my job is to go and create that sum of n. Okay, then just accept that as a, if you are passing as an argument, you need to accept that as a parameter. Okay, so till now done. Let me erase all these things. So till now done. Now what we need to do, so we just need to return the generalized formula. What is our generalized formula? N plus sum of n minus 1. That's it. That is what we wanted to return. So this is our, like, this helps us to solve our problem. Okay, when do we need to stop? So can I say we need to stop at whenever we have seen the minimum sub problem that we can solve. So in this case, the minimum sub problem that we can solve is when n is equal to 1. We know the answer for that. Okay, we know the answer for that. So if n equal to 1, just return 1. Done. Python pattern. Okay, cool. So we'll have a separate session on patterns. Okay, sure, that's a good thing. Okay, so yeah, we'll have a separate session on patterns. Okay, so whenever our n becomes 1, we need to stop that. Okay, how can we stop? Let's say we have seen that, right? So we will be returning 1. Okay, we will be returning 1, that's it. Okay, so how this is going to execute? Okay, how this is going to execute? So I will show, I can show you with a debugging point. Okay, like let's say, let's put some debugging points here. Okay, let's put some debugging points. So now let's execute this piece of code in the debugging mode. Okay, I've clicked on execute. So why I'm showing this in a debugging mode? Like why not just run that code? So if I run that code, I will get an output. I know that I will get an output. I will know that. But how if you wanted to learn how this is being processed, then you need to see in a debugging mode. Okay, then only you will get to know what is happening at line by line. Okay, so we are currently at 6th line. Okay, now we have seen that our n value, so you can see the n values here. Okay, you can see the n value here. Even you can observe the n values here. Okay, so that's not a big deal. Okay, now so it is checking that if my n is equal to 1. Okay, whenever it checks with whether n is equal to 1, it is fails. Okay, n is not 1, it is 5 now. Okay, then I will go to the next step over. Okay, now my control has been reached here. Now again I have checked. Okay, now what happened? My n got reduced to 4. Yes, earlier it was 5, and again it called the same function. Okay, it called the same function, and my n became 4 this time. Yes, now let's go. Okay, again I come to 4th line, and again I came to 2nd line. Okay, if you observe, this is what recursion means, right? Recursion. So it is calling the same function again and again. So it is coming to 4th line, again it is going to 2nd line, it is coming to 4th line, again it is going to 2nd line. Okay, so now my n is 3. Okay, I came to 4th line again, then again I went back. Okay, and again I came to 4th line, and again I went back. Now this time my n is equal to 1. Now let's see what happens. Okay, let's see what happens. So now I am putting step over. So I got entered into 3rd line because my n is equal to 1 currently. And even if you could observe this, okay, how many times sum of n has been created here? 1, 2, 3, 4, 5. 5 times. Okay, here. Okay, here. So it's a 5 times. Okay, so why 5 times? Because we are calling this function 5 times. That is what it is saying that. Okay, so for each function call, it is creating one layer. Okay, you can say that this storing all of them in a stack manner. Okay, one stack. So what is the operation of a stack? So it is I can say that it's a last in first out. Okay, whatever you put at the last, you will be taking at that particular thing the first. Okay, you can simply say that it's a bookshelf kind of stuff. Okay, let's say you are putting all your books. Okay, so first you have placed your first book, then second book, then third, then 4, then 5. Okay, now if you wanted to take one book out, what will be the first book that you will be taking out? Can I say it is the first it is the 5th book which has been placed at the last? So that is what happens. So here the last the top of the stack here is line number 3. Okay, so this one, so this is going to execute. Okay, now if I click on continue, again I came to here. Okay, even you can see here we have reduced by 4. We came to 4. Okay, 4 function calls. Now if I again click on this, now again it got reduced and my n is 3 now. Okay, so now it's a 4, now it's a 5, now it's a done. Okay, we got our answer. So if I go to console, I got my answer. So we'll first go down, 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 and we'll reach 1, and from that one we will be coming back to the top, okay, by doing whatever task we wanted to do. Okay, this is how a recursion works. Got it? Still you have any doubts how recursion works? Okay, if you have any doubts, please let me know, please let me know. Okay, this is very important topic. Okay, so you have to learn a lot. Okay, there will be a lot of connected topics to this beta backtracking, beta dynamic programming. Okay, you need to understand full-fledgedly. Okay, that's my intention. So why I am taking this much of time for a simple problem. Okay, it's not about solving one problem, it's about solving 5 to 6 similar kind of problems. That is what an ideology here. Okay, now let's go and solve another problem. Okay, let's go and solve another problem. It is going to be similar problem. Okay, I will tell you the problem statement. Now you need to tell me the generalized formula for that. Okay, so you know what is a factorial of a number, right? Factorial of a number, right? So if I give n is equal to 5, now how can you write this? You can write something like 1 into 2 into 3 into 4 into 5. Okay, so yeah, now what I am expecting from you guys is a generalized formula. Generalized formula. Yeah, hello gamer. Okay, hello gamer. So I'm expecting a generalized formula from you guys. Okay, so just try to relate this problem to the previous problem, you will get it. Okay, so now can I ask few questions? If you are not able to relate it, if you are not able to generalize the problem, so just try to answer my questions. Yes, good Shraddha, good, that's correct. So now can I say if I want the factorial of 5, if I want the factorial of 5, can I say if I multiply 5 into whatever the factorial of 4, I will get my answer. Yes, I will get my answer. So it goes for the same until it called factor of 1. So this is the least sub problem that we can solve. Okay, if n is equal to 1, like what is the factorial of 1? Can I say the factorial of 1 is 1? Yes, can I say factorial of 1 is 1? So here I will return 1. So I will keep on going. So okay, 3 into fact of 2 of 4 into fact of 3. Okay, something. So if I generalize this, I can write it as a n into fact of n minus 1. Yes, done. So why we have solved this? We know the formula. We have seen a generalized here. We have seen a relativeness between two things. Okay, 5 and 4 we have seen a relativeness. And we know the smallest sub problem answer as well. Okay, that's why we are able to solve this. Okay, let's go. Yeah, so we can do just an into here. Okay, and let's change the name to the fact. Okay, here okay, so here I can get some, yeah, so here I can get a fact. Okay, now if I execute this, yeah, I got a 120. So are you able to visualize the tree? That's the important thing. Are you able to visualize the tree which we have drawn earlier? Are you able to visualize the tree? That is important. Okay, that is important. Visualization of tree. So recursion comes with an visualization. Unless you are not able to, like, you are able to visualize the trees and visualize the problems, then you can solve the recursion problems as well as dynamic programming problems as well. Okay, so if you're not able to visualize the things, and if you're not able to relate the things, then it will be tough. Okay, I won't say tough, but yeah, it requires more practice. Okay, it requires more practice. So for me, I have solved more than like after solving more than 60 to 70 DP problems on lead code, then I got to know, yeah, this is the relation. So this is how we need to solve. This is how we need to visualize the things. Okay, so yeah, practice comes. Okay, practice makes man perfect. Okay, now let's solve another type of problem. Okay, let's solve another standard DP problem. Sorry, recursion problem. Sorry. So let's say a Fibonacci number, Fibonacci number. So can you help me to draw the tree here? Let's say if I say I want a fib of 5, what is the generalized formula? Like what is the thing I need to do? So if I want the fib of 5, I need to add the fib of 3 plus fib of 4. Agree? And if I want the fib of 3, like let's go with fib of 4 first. Okay, fib of 4, then what do I need to do? I need to do fib of 2 plus fib of 3 plus fib of 2. Means a Fibonacci of, I need to first find the Fibonacci of 3, then I need to find the Fibonacci of 2, then I can say this is the Fibonacci of 4, right? That is how it works, right? Like if I'm standing at A, like let's say A, B, C, now if I wanted to know the fib of this particular C, then the formula would be A plus B, right? Like if I add the previous two numbers, then I can find the fib of two numbers, like fib of current number. Okay, so adding previous two numbers, okay, then only I will get a fib of Fibonacci number of current number, right? So how can we do this? Okay, this is how, right? This is how. So we need to go next, fib of 3. So fib of 3 is equal to 2 plus fib of 1. So until at what number, what is the smallest subproblem that we can solve here? What is the smallest subproblem that we can solve here? So just think in case of universal numbers. Okay, so everyone knows the starting two numbers of a Fibonacci number. Everyone knows the starting two numbers of a Fibonacci number. Can I say that? So the starting, a fib of 0 is going to be 0, fib of 1 is going to be 1. So if I know these two numbers, and if I know the formula, this formula, can I solve any problem? Like can I find any Fibonacci number? So I can say that. Why? Because there is a relativeness. The current number is based out of the two previous numbers. Okay, so at that case, what I can do? I can say we can solve this problem using recursion. Okay, understood? Yes, Shraddha. Good. Okay, so that then the generalized formula will be is going to be generalized formulae is going to be fib of n is equal to fib of n minus 1 plus fib of n minus 2, right? Fib of n minus 1 and fib of n minus 2. And what is the smallest subproblems? What are the smallest subproblems? So we can call them as a base cases as well. Base cases. Okay, base cases. So can I say if n equal to 0, it is going to be return 0, and n is equal to 1, you need to return 1. Agrees? These are all the smallest subproblems that we can solve, right? Now let's go and try to solve this particular problem. Okay, try to code this up. Okay. Okay, so at first let me make this as a Fibonacci number. Okay, Fibonacci. Okay, Fibonacci. Now what will be the generalized formula? So it is going to be Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, n minus 1 plus n minus 2. And what will be the return conditions? So if n is equal to 1, we need to return 1. So before that we need to check if like n is equal to 0, just return 0. Yes. Fib of 3 is going to be fib of 2 plus 1, right? Fib of 2 is, again it is going to be fib of 1 plus 0. So we know the answer for fib of 1 and fib of 0. So it is going to be 0 plus 1. So it will return 1 for fib of 2. Okay. For fib of 2 is this 1, and fib of 3 is going to be fib of 2 plus fib of 1. So it is 2. Okay, that's how it works. Okay. Let's see. Okay, let's see. Yeah, we got the 5, and for better understanding you can just try to put it in a debug mode. Okay, put some breakpoints, then run it in a debug mode. You will get to know what is happening in clear. Okay, clear and cut. Okay, so yeah, so here I want to discuss another problem, like not another problem. So yeah, I just wanted to discuss the drawback. Okay, the limitation, like the major drawback of a recursion. So in programming world, recursion, many people feels that recursion is not an efficient way of solving problems. Okay, if there is an alternative solution for the recursion, then they will prefer that particular solution instead of a recursive solution, because people think that recursive is a very slow. Okay, it makes unnecessary complicated. Okay, it makes a problem little complicated. So why people will think that? So why return 1? Why? So like these are all the very smallest sub problems that we can solve, right? So when n is equal to 1, like if I want the Fibonacci of 1, what will be the Fibonacci of 1? It is going to be 1. And what will be the Fibonacci of 0? It is going to be 0. So we can't go down that. We know that answers very clearly, right? So if we know that basic problems, like smallest sub problem, then we can build our logic on top of that, and we can find the for Fibonacci number of any number. Okay, if there is a relationship. Yes, there is a relationship. Okay, so that's why. And yeah, I just wanted to show you the drawback of using recursion. Okay. Here. So let's try for Fibonacci of 4. Okay, Fibonacci of 4. So for finding Fibonacci of 4, what are we doing? Can I say we are adding fib of 3 plus fib of 2? Yes, can I say that? Now if I want the fib of 3, again what do I need to do? I need to do fib of 2 plus fib of 1. Yes. Now again fib of 2, it is going to be fib of 1 plus fib of 0. Okay, and for fib of 2, it is going to be fib of 1 and fib of 0. Now at the each end, like whenever I have seen n is equal to 1, I will return 1. Whenever I have seen n is equal to 0, I will return 0. 1, so we will return 1. So here we will return 1, will return 0. Yeah, like so here it's plus operation, so 1 plus 0, it is going to be 1, and here it will return 1, so it is going to be 1 plus 1, it's going to be 2, and here it is going to be 1 plus 0, so 1, so 2 plus 1, it is going to be 3. So I'm good. Okay, did you observe anything? Did you observe anything? What is your observation on this particular tree? Did you identify something going wrong? Yes, tell me, tell me. Did you observe something going wrong? Something. Did you observe? Open up. Okay, like irrespective to whether it's a wrong or right, you should need to communicate first. Whether if you do if you wanted to know whether your answer is right or wrong, you should first communicate. Okay, you should express, then only. So ask, then get it. Okay, don't be silent. Okay, so can I say I'm solving the same problem again and again? Yes, can I say that? Let's say here I am solving fib of 2 here. Okay, I am solving fib of 2 here. Okay, I am solving fib of 2 here. Now again I am solving fib of 2 here. Again I am solving fib of 2 here. Right? How many function calls I am making for finding a fib of 2? Can I say for fib of 2 I am making 2 calls. Now how many times I am calling fib of 1? Just count it. Okay, how many times I am calling fib of 1? It is 1 time, 2 times, 3 times. So for finding fib of 1, 3 times. Now my question is, so every time whenever I am calling a new call, okay, whenever I am calling a sub problem of fib of 1, will my answer will be same, or is it going to change every time? Okay, will my answer of fib of 1 is going to be same or different for each call? So can I say that? So how many times, like irrespective of how many times you will call that function, your answer is going to be same? Yes, can I say that statement? But what is the need of solving that particular problem again and again, again and again? What is the need of? What is the need of solving that problem again and again? So can I say that it is making our application little slow? So let's say for each function call it will take 1 second. Assume for each function call it will take 1 second. Okay, so now at max, okay, so here how many seconds it will take for all this tree? So can I say 1 2 3 4 5 6 7 8 9 times? Okay, 9 seconds. It is going to take 9 seconds. It is going to take 9 seconds because we have 9 function calls, right? Now if just assume instead of it is calling the same function again and again, if it has solved only one time, if it have solved particular problem only for one time, then it could have taken, so 1 2 3, so we have already computed fib of 2, so okay, I won't make this call, just assume here. Then 1, so fib of 1, so again I have solved fib of 1, so I need to make a call for fib of 0 because I haven't solved that problem yet. Then I have solved fib of 1, I have solved fib of 0. Now if I count, it has taken only 5 seconds. Now which one is efficient? Now tell me which one is efficient. The one which is reducing the number of calls is the one is very efficient because we got the answer in within 5 seconds. Yes, blunt art, hi, just join now. It's okay. Okay, so we have there is an option to go back and watch the entire video. Okay, that's what I suggest. Okay, we are just going in a flow. Okay, so if you know functions, what is a function, and if you know how to make a function call, then you can watch this particular video from the starting. I can say that you will definitely get a benefit. Okay, now tell me which one is efficient, guys. It is going to be one which is taking 5 seconds, because as a user I want the one which is very efficient, which is very quick in responding, right? So I will prefer 5 seconds one. So this is the drawback of an recursion. Okay, this is the drawback and recursion. So how to convert this? Okay, how to make this as an efficient one? Here comes the dynamic programming. Okay, here comes the DP, dynamic programming. Okay, I will just tell you in a glance what a dynamic programming means. Okay, I will tell you in just a glance what dynamic programming means. So okay, I will just do two things. Okay, I will just do two things. So whenever I made an call to fib of n, okay, fib of n, I will just check whether that problem is being solved earlier or not. Okay, solved earlier. Okay, let's say if I'm making a call of fib of 2, I will just check whether I have solved that particular previous like fib of 2 previously or not. If yes, if I have solved that particular problem previously, if it is S, okay, if it is S, I can say that get that answer. Okay, if I have solved that have solved that problem earlier, just get that answer, because I am pretty much sure that your answer is not gonna change. Okay, and if your answer is no, like if you haven't solved that problem yet, then what you need to do? You need to solve the problem. So this is what a dynamic programming means in a high level. Okay, in a high level. So hope you have understood, yes, like how dynamic programming works at least. Okay, like if I wanted to tell you in a real world example, okay, I can say if I asked you to figure out, sum of sum of 5 plus 10 plus 8 plus 9. Now what is the sum of this? What is the sum of this? What is the sum of these values? Can I say that it is going to be 42 or 32? Sorry, 32. Yes. Yes. You are gonna say that 32. Now if I ask you to figure out the sum of 5 plus 10 plus 8 plus 9 plus 2. Now what will be your answer? What will be your answer? Can I say that you are going to say 34 very quickly? How? Because you have identified that you have solved this particular problem earlier. Okay, you can just remember that now, like as a humans. Okay, we can just remember that answer, right? So because we have solved that just now, we can remember that in our brain, and as soon as I figure out that it is the same problem, okay, it is just a slight modification, I can just say I can replace this entire thing with the 32, and I can just add 2 to it, and I will say 34. This is what we do generally, right, as a human beings. Yes, everyone agrees that. So this is what a dynamic programming means. Okay, this is what a dynamic programming means. Just remember, whether you have solved that earlier or not, then just go ahead and do. That's it. Okay, so yeah, we'll solve a good amount of problems using dynamic programming as well, okay, in future. So yeah, so you need to just make sure that you attend classes regularly. So yeah, we'll solve dynamic programming as well, as we have discussed recursion. So I made recursion. I hope you have understood recursion. Okay. So even if you are saying recursion for the first time, hope you got it. Now I will give you a small assignment, guys. Okay. Like we have solved some good amount of problems with loops. Okay. um, with loops, right? So I can say that just try to convert your loop problems into recursive problems. Like I will tell you the names of the problems as well. Okay, let's say count the digits, count the digits and count the digits, sum of digits and a sum of list elements and a reverse of a string and a list. Okay, I guess it is going to be little good problem. Okay, I will discuss it tomorrow as well. Okay, I will discuss this reverse of a string, okay, or list. Okay, using a recursion. Okay, I will discuss this particular problem tomorrow. And yeah, so and if you got in some time, just go through some articles or blogs about head recursion and a tile recursion. Okay, just go through these things and let me know in tomorrow session whether you have understood this head recursion and tile recursion or not. Okay, we'll discuss that. Okay, I just don't wanted to discuss that because it's very easy to understand and you can find good amount of articles on that. Okay, so just go through them and let me know in the tomorrow session whether you have like you haven't understood the head recursion and tile recursion concept. We'll discuss that. Okay, that's not a complicated one, it's very easy, only one difference. Okay, you will get it. Okay, you will get it for sure. Okay, just try with the problem, like try to code. Okay, then you will get it. Yeah, and yes, that's pretty much, I guess. Okay, and if you have any questions you can ask me, otherwise we'll catch up tomorrow at the same time with some few more recursive problems. Okay, I guess we are good and we have solved a pretty good amount of problems today. Yeah, done. Okay, see you, bye bye, see you tomorrow. Okay, at the same time.